Hello everyone. This week's lecture will cover Module 13 and is divided into two parts. Here in Part 1, we will discuss alcohols. From this module onward, we will discuss compounds that are derived from hydrocarbons. Derivatives of hydrocarbons are compounds that have a hydrocarbon parent chain in which one or more hydrogen atoms have been replaced by one or more of the functional groups we discussed in Module 8. The derivatives that we will cover in Chem 1 include alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, amines, and amides. Alcohol is a familiar fixture in our daily lives. We use ethyl alcohol and isopropyl alcohol as disinfectants, and we consume many types of alcoholic beverages, from beer to brandy. In organic chemistry, alcohols are defined as a homologous series of organic compounds with a general formula CnH2n+1OH, where N represents the number of atoms. Alcohols are named and identified by the suffix OL. As a derivative hydrocarbon, the hydroxyl group OH replaces one hydrogen atom in the hydrocarbon chain. There is no specific date of discovery for alcohols as a group of organic compounds. The creation of alcoholic beverages was a result of the discovery of the natural process called fermentation. These beverages are believed to have been consumed by humans since around 9,000 years ago. The earliest record of alcoholic beverage production is from China, where various kinds of fruits were used to make wine. On the other hand, the discovery that alcohol could be used as a disinfectant and antiseptic occurred sometime in the 1300s. Alcohol was used as a general anesthetic prior to the development of modern agents for anesthesia. Here are some chemical and physical properties of alcohols. Alcohols are polar because of the hydroxyl group, which has an electronegative oxygen atom. Alcohols with a small number of carbon atoms can mix with water because their molecules can form hydrogen bonds with water molecules. However, larger alcohols are not soluble in water. The boiling point of alcohols is higher than alkanes of similar molecular mass. For example, methanol has a boiling point of 64.7 degrees Celsius. On the other hand, ethane has a boiling point of negative 88.6 degrees Celsius. Alcohols can be classified into three main types based on the number of R groups attached to the hydroxyl-containing carbon atom. Primary alcohols have one R group attached to the carbon to which the OH group is attached. Secondary alcohols have two R groups attached to the carbon to which the OH group is attached. And tertiary alcohols have three R groups attached to the carbon atom to which the OH group is attached. This alcohol is a primary alcohol because it has only one R group attached to the carbon bonded to the OH group. This alcohol is a secondary alcohol because there are two R groups attached to the carbon bonded to the OH group. And this alcohol is a tertiary alcohol because there are three R groups attached to the carbon bonded to the OH group. Please note that the positions of the OH and R group can vary. This is because any of the hydrogen atoms attached to carbon can be replaced. Let's practice classifying alcohols according to the main types, starting with this alcohol in A. First, we need to identify the carbon atom that is bonded to the hydroxyl group. In this compound, this is that carbon. Then we count how many other carbon atoms are attached to this carbon. Here we can see that there are three carbons attached to it. So this compound is a tertiary alcohol. Now let's go to B. The carbon bonded to hydroxyl is this carbon. There is only one carbon attached to it, which makes this a primary alcohol. Let's go to C. The carbon attached to hydroxyl is this carbon. There are two carbons bonded to it, which makes this a secondary alcohol. Finally, in D, we have a benzene ring with a hydroxyl group. In Module 12, we learned that this compound is called phenol. Phenol is actually a type of alcohol. Now let's identify the carbon bonded to OH, which is this carbon. There are two carbons bonded to it, which makes phenol a secondary alcohol. Naming alcohols follows the same IUPAC nomenclature system as saturated and unsaturated hydrocarbons. First, we have to find the longest carbon chain containing the carbon with the OH group. When naming alcohols, we simply drop the E from the alkane name and replace it with -ol. For example, when methane becomes an alcohol, the name changes to methanol. Then, we number the carbons in the chain, starting from the end closest to the OH group. Then, we number and name all the substituents. If there are more than one substituents, we arrange the substituents alphabetically. Here are the first 6 simple alcohols based on the number of carbons, their molecular formulae, and name. These simple alcohols have alkanes as the parent chain. So, an alcohol with one carbon atom is called methanol. When there are 2 carbon atoms, the alcohol is ethanol. A 3-carbon alcohol is propanol. A 4-carbon alcohol is butanol. A 5-carbon alcohol is pentanol. And a 6-carbon alcohol is hexanol. Now let's practice naming and drawing simple alcohols. Naming alcohols is similar to naming hydrocarbons. First, we must find the LCC. Since this is an alcohol, the hydroxyl group must be part of the LCC. This compound has 1, 2, 3, 4 carbons. A 4-carbon alkane is called butane. To name the alcohol, we simply remove the E and replace it with OL. So this alcohol is butanol. Then we number the carbon atoms. When numbering the carbons, the carbon with the hydroxyl group must be given the lowest number possible. So in this case, we have to number from left to right. This is carbon number 1, 2, 3, and 4. So the hydroxyl group is attached to C2. To indicate that, the full name of this compound is written as 2-butanol. Now let's try drawing this compound. We start by drawing the parent chain, which is propanol. Propanol has 3 carbons, so we draw 3 carbons here. The hydroxyl group is attached to carbon 1. We can have this as carbon 1 or this as carbon 1. Either way is correct. Let's put the hydroxyl group here. Then we fill in the missing bonds to complete the octet rule of carbon. Okay. So we have 1 propanol. Then we draw the substituent, which is methyl. Methyl is attached to carbon 2. So this is carbon 2. We can attach methyl up here or down here. Methyl is CH3. So we can draw here CH3. So this is the structure for 2-methyl-1-propanol. Let's try naming one more alcohol. This is a cycloalkane with a hydroxyl group attached. There are 1, 2, 3, 4, 5, 6 carbons in this cycloalkane. A 6-carbon cycloalkane is called cyclohexanol. Now we need to number the carbons accordingly. The carbon to which the hydroxyl group is attached is automatically given the number 1. There are 2 substituents in this cyclohexanol. We have to number clockwise to give the substituents the next lowest number possible. So this is carbon 2, 3, 4, 5, 6. Then we name the substituents. This is the halogen bromo. And this is the alkyl methyl. Then we add the number of carbon to which they are attached. So this is 3-methyl and 3-bromo. When writing the full name, we arrange the substituents alphabetically. So the full name of this alcohol is 3-bromo, 3-methyl, cyclohexanol. Let's try naming one more alcohol. This is a cycloalkane with a hydroxyl group. There are 1, 2, 3, 4, 5, 6 carbons in this cycloalkane. A 6-carbon cycloalkane with a hydroxyl group is called cyclohexanol. Now let's number the carbons in cyclohexanol. The carbon with the hydroxyl group is automatically given the number 1. There are 2 substituents in this alcohol. They are attached to the same carbon. We number clockwise to give the substituents the next lowest number possible. So this is carbon 2, 3, 4, 5, 6. Now we name the substituents. This is the halogen bromo and this is the alkyl methyl. We add the carbon number to which they are attached before the name. When naming alcohols, we arrange the substituents alphabetically to get the full name of the compound. So, the full name of this alcohol is 3-bromo, 3-methyl, cyclohexanol. Alcohols with 3 or more carbon atoms display positional isomerism. Thus, to avoid confusion, the number of the carbon to which the hydroxyl group is attached is written before the OL. This is a 3-carbon alcohol called propanol. The OH is attached to carbon 1. This is also a 3-carbon alcohol called propanol, but the OH group is attached to carbon 2. To avoid confusion, between the two compounds, we name this one as propan-1-ol and this one as propan-2-ol. Let's try naming these two isomers. They both have 6 carbons, so they are both hexanol. In this hexanol, the hydroxyl group is attached to C1, so we name it as hexan-1-ol. In this other hexanol, the hydroxyl group is attached to C3, so we name it as hexan-3-ol. Remember that any of the hydrogen atoms in the hydrocarbon can be replaced by a hydroxyl group. Many alcohols have more than one hydroxyl groups. We name them by attaching a number prefix before the ol. If there are 2 hydroxyl groups attached, we use the prefix di. If there are 3 hydroxyl groups, we use the prefix tri. Let's try naming these 2 alcohols. This alcohol has 2 hydroxyl groups. This one has 3 hydroxyl groups. This alcohol has 6 carbon atoms. So, we name it as 1,6-hexane-diol or hexane-1,6-diol. This other alcohol also has 6 carbon atoms. We name it as 1,2,6-hexane-triol or hexane-1,2,6-triol. Note that the numbering of carbons in this alcohol is from right to left because the hydroxyl groups must be given the lowest number possible. Unsaturated hydrocarbons, the alkenes and alkynes, can also form alcohols. When naming, the hydroxyl group has a higher priority, so we assign the carbon attached to the OH the lowest number. We also need to indicate the carbon number where the double or triple bond is located. Naming unsaturated alcohols is the same as that for alkanes. We drop the E and replace it with ol. Here we have 2 unsaturated alcohols. This alcohol has 5 carbons, so we name it pentanol. The numbering is from right to left so that the OH will have the lowest number. The double bond is located in C4, so the full name is pent-4-n-2-ol. This other alcohol has 4 carbons. It has a triple bond, so we name it butenol. The OH group is in C1 and the triple bond is in C2, so the full name of this alcohol is butyne-1-ol. Let's practice naming unsaturated alcohols. Our first alcohol is from an alkene because of this double bond. First, we need to find the LCC. The LCC must include both the double bond and the hydroxyl group, which means this is our parent chain. Our parent chain has 1, 2, 3, 4 carbons. A 4-carbon alkene is called butene. To name its alcohol, we simply remove this E and replace it with OL, which gives us butenol. Then we number the carbons according to priority. The carbon with the hydroxyl group has higher priority over the double bond, so numbering should be from right to left, which means this is carbon 1, this is 2, this is 3, and this is 4. The hydroxyl group is attached to carbon 1, so we change the name butenol to indicate this position. Buten-1-ol. The double bond is located in C2, and we also need to indicate this in the parent chain name. So the parent chain name is 2-buten 1-ol. Then we name the substituent. This alcohol has one substituent, a 2-carbon alkene, which is ethyl. Ethyl is attached to carbon 2, so we have to write that here. Then we combine the substituent name to the parent name. So the full name of this alcohol is 2-ethyl 2-buten 1-ol. Now let's try this other compound. This alcohol is from an alkyne because of this triple bond. We need to find the LCC. The LCC must include both the triple bond and the hydroxyl group, which means the entire compound is our LCC. This alcohol has 1, 2, 3, 4, 5, 6 carbons. A 6-carbon alkyne is called hexyne. To name its alcohol, we simply remove the E and replace it with ol, which gives us hexenol. Let's now number the carbons. The hydroxyl group has higher priority in the numbering, so this carbon should be given the lowest number possible. 1, 2, 3, 4, 5, and 6. Now we need to indicate the position of the hydroxyl group in the name. The hydroxyl group is attached to carbon 1, so the name becomes hexene 1-ol. But we also need to indicate the location of the triple bond, which is in carbon 5. So we can name this alcohol as 5-hexene 1-ol. That's it for our lecture on alcohols. In this lecture, we learned that alcohols are derivatives of hydrocarbons with a hydroxyl functional group. Alcohols are either primary, secondary, or tertiary. Alcohols are named using the suffix -ol. There can be more than one hydroxyl group in one alcohol compound. And alkenes and alkynes can also form into alcohols. And that ends Module 13. Modules 13 and 14 will have a combined activity worksheet. Please refer to Module 14 for the activity instructions. Thank you for listening.